on your slope field worksheet to help you complete that. Number 2, we skipped in class today in our hurry, so I'm going to do the slope at 0, 0, and all we need is our y value. So when y is 0, the slope is 0. And then at the point 1, 1, or 2, 1, 3, 1, negative 1, 1, and so on, all of those slopes are going to be 2y, so the slopes are going to be 2. So they're pretty steep here, all of these points. Trying to get them all to be a little steeper than 1. At the points right here, like 1, 2, 2, 2, 3, 2, and so on, all the way across where y is 2, your slope's 4, which is pretty steep. Probably a little steeper. Steep, steep, steep. And we have dots here. Alright, so everywhere that y is 0, like 1, 0, our slope is 0. And then where our slope's 1, negative 1, 2, negative 1, and so on, those are all going to be negative 2. So try a little steeper than negative 1. And then where we have the point 1, negative 2, 2, negative 2, and so on, we just need our y values. So it'll be even steeper, negative 4. This was 0, negative 1, so I have to be careful there. Sorry, these along the axis are wrong. This point is 0, 1 right here. This point is 0, 1. And so that slope would have been 2. And this point is 0, 2. And the y value is 2. So that would be steep and parallel along with these other ones, a little steeper. Okay, so that's your slope field. Now what would happen here, you don't have to write this on your homework, but what's going to happen is we're going to learn what's called separation of variables also. And so I'm going to move this dx over here and separate my variables. However, true separation of variables to find the particular solution means that you actually get all your y's on one side and your x's on the other side. I'll keep telling you during class, just take the y, don't take the 2. So just move the y over. Your life's going to be easier if you leave the 2 behind. Most people would move the 2y over, and it's just a little bit harder. All right, now the antiderivative of 1 over y, you're not very good at yet, but it's ln y, and the antiderivative of 2 is 2x plus c. Now to find the particular solution, you've got to solve for y. So this is base e to the 2x plus c equals y. You can drop the absolute value, which we'll probably talk about in class at some point. Now using my algebra, this is the same thing as e to the 2x times e to the c. Since the exponents are added, that's what you would do if you're multiplying. You would add your exponents. And e to the c is just 2.718 to some power. And so that's really just a bigger constant. So I just call this e to the c. Normally I'll just call that a constant e to the 2x. So our equation is y is equal to c e to the 2x. And if you graph some of those, like if I graph y equals like 3e to the 2x, your graph looks somewhat like this, 3e to the 2x. And if you have like negative 3e to the 2x, it flips it over this way, which makes sense with these graphs that we're seeing on our display here. I was trying to think, is there anything else I wanted to say? There's a way on your calculator to do slope fields, but I'll just do it this way for now. And you don't really need to ever know how to do slope fields on your calculator. We won't look at all of them. Let me see if the TI comes up here. And going into, I was doing 3 in class. Let's do number 4. All right, so this is number 4. Number 4 is dy over dx equals 2x. Alright, so all I really need is the x values. So whenever x is 0, 0, 0, 0, 1, 0, 2, we have 0. Okay, and then out here are our ones. 1, 0, 2, I'm sorry, 1, 1. I'll just climb up. 1, 2. We want to be careful to think about each point. At 1, 0, 2 times 1 is 2. It's pretty steep. At 1, 1, all you need is your x value, so these are all parallel, but don't try to move too fast. When x is 2, like 2, 0, 2, 1, and so on, we need our x value, so we get 4, so it's pretty steep, steeper than the one we did before these. I'd probably really go back and redraw them a little bit, not quite so steep. I got carried away there. And then when x is 3, I need a little more room for even steeper. These are almost vertical, up 6 over 1. So these I might slightly change a bit if I was going to erase them. And then when x is 0, we had 0. Okay, and then when x is negative 1, 0, negative 1, 1, my slope is negative 2. And then when x is negative 2, my slope is negative 4. So a little steeper. And then negative 6, so even steeper. Okay, now it's interesting to look at this one. If I separate my variables and move my dx over here and integrate, I get y is equal to 2x squared over 2 plus c, or some form of x squared plus c. And you can see that my points look like they're following that path of an x squared plus c. And if I give you a specific point, which we'll see later, we would be able to do that. Let's see if the calculator's opened up yet. Okay, so if I go back to what we had, like if I have 2e to the, I can't remember what the equation was, 2e to the, right here, e to the 2x. We don't really know what our constant is. Maybe it was going to be negative 3 e to the 2x. We don't know what c is. Well, I'll show you how to find it, but right now we don't know what it is. We'll do it on another one. But if I graph both of those, change my window, like negative 4 to 4, kind of like our little slope field we've got here, negative 4 to 4. Okay, so let me pull that in here. You can kind of see like how that slope field makes sense. And one thing, we didn't go very far back with our y. But you see how it, if I followed it like a flat line almost at 0, and then it goes up really steeply like this does. And right here we have kind of a flat line, and then it comes really steep really fast. So anyway, we'll talk about that some more. Now all you had to do really on 2 was draw the slope field, and on 4 draw the slope field. So on the next one, number 5, I'm just going to draw the slope field. And I probably won't do separation of variables. So to talk any more about it, on 5, we have dy over dx equals y minus 1. So just start somewhere. We'll start at 0, 0. And so y is 0 minus 1, so I have negative 1. At 0, 1, I get 0. At 0, 2, I get 1. At 0, negative 1, I get negative 2. And at 0, negative 2, I get negative 3. So a little steeper. At 1, 0, I get negative 1. So everywhere that y is 0, you're going to get negative 1. And when you just have one variable to deal with, it's a little bit easier. So at all the 1, 1, 2, 1, and so on, your slope is 0. At 1, 2, 2, 2, 0, 2, and so on, your slope is 1. Y equals x. Okay. At 0, negative 1, 1, negative 1, all your negative 1s, your slope is negative 2, so a little steeper. And then at 1, negative 2, 0, negative 2, your slope is negative 3. So try to get a little bit steeper than whatever you said the other one was. And so something depending on where you are, where you start your graph, it could go in either direction here, but we'll talk about that more. Let's just get our slope fields done. All right, on number 6, we have dy over dx equals negative y over x. So at 0, 0, you notice that 0 is on the bottom, and so it's undefined. In fact, 0 over 0 is probably actually a hole in the graph, so we'll just kind of hold off on that one. A lot of times they wouldn't even put a dot there for you to consider, but for now, we can go back and talk about it. Let's do 1, 0. 1, 0, 0 over 0 is an indeterminate form. Let's just let that go for a minute. 1, 0 is going to be negative 1 over 0. So at 1, 0, it's undefined, which means we have a vertical tangent. And the same thing at 2, 0, and all of these. These are vertical lines. This, we're not really sure what's going on at the origin. But they didn't really put a little dot there, so I'm not going to find it. All right, at 1, 1, so I'm right here. At 1, 1, I get negative 1 over 1, so I get negative 1. At 1, 2, right here, I get negative 2 over 1, so I get negative 2, so a little bit steeper. At 0, 1, I get 0. At 0, 2, I get 0. At 0, negative 1, and 0, negative 2. Y on the, oh, I'm sorry, those are wrong. Okay, I'll think one more. All right, at 0, 1, be careful. I get negative 1 over 0. So did I do this one wrong? Let me start this over, sorry. Okay, still ignoring the origin because it's an indeterminate form. Let me see if I can get this right now. All right, so at 0, 1, you would get negative 1 over 0, so this one would be a vertical tangent right here. At 0, 2, you would get negative 2 over 0, so vertical, vertical, vertical. At the ones on the axis, like 1, 0, 2, 0, those would be horizontal. It's kind of crazy. All right, then at 1, 1, your slope is negative 1. I'll go back to white now. All right, at 2, 2, the same thing happens. I get negative 1. Everywhere your x and y are the same. At negative 1, negative 1, I would get negative 1. And at negative 2, negative 2, I would get negative 1. All right, so let's go to, what's that, 2, 1? 2, 1, I get negative 1 over 2. So it's negative, but tending a little bit more. At 3, 1, I get negative 1/3, so even a little more horizontal. I missed this one right here, so 1, 2 would give me negative 2 over 1, so this is pretty steep. At 2, 2, I guess I haven't done that one. Oh, 3, 2. 3, 2 right here. I get negative 3 over 2, or negative 1.5. So So this was -2, this was -1. So this is -1. Let's see, was that -1, 2, 2? Okay. And so 3, 2, sorry, I knew something was wrong there. 3, 2 is -2/3, which is why I say write them down. I was trying to do it in my head even though I wrote it down. So -2/3 is a little bit, just a little bit more horizontal than -1, hard to draw. All right, so -1, 1 will give you 1. -1, 2 would give me -2 over -1 will give me 2. A little steep there. -2, 1 would give me 2. -2, 2 would give me negative of -2 would give me -1. Wait, something's wrong there. Oh, -2, 2. So this is positive. So this would give me 1. That's why I'm saying don't do it in your head. I'm having trouble even not doing it in my head. -3, 1 will give me -1 over -3, or 1/3, which is -3, 1. Alright, so it's positive, but kind of level. Let me double check this one. -2, 1 will give me -1 over -2 will give me 1/2. So I got -2, 1 wrong. I put the wrong one over it. So be careful. Sorry about that. So be careful. Don't get in too much of a hurry, even though you're kind of easy. Alright, -3, 2. Y over -y over x, so I get 2/3, which is a little bit less than 1. Alright, and these are horizontal. Okay, now I'm at 1, -1, and that would give me 1. 1, -2, be careful, would give me 2. Sorry, I hadn't found that one yet. 2, -1 will give me 1/2. And 3, -1 will give me 1/3. 2, -2 would give me negative of y over x will give me 1. And 3, -2 will give me 2/3. So a little bit more. Okay, what do I have here? -2, -1 would give me a -y over x, -1/2. And -3, -1, y would be positive over -3, -1/3. -2 would give me 2 over -2, -1. And -3, -2 would give me 2 over -3, about like that. Alright, so that's your slope field there. Now on that one, I do want to show you what's happening here. Alright, so what happens when you get a slope field? I didn't really get to talk totally about today. What's so cool is that your derivative, dy over dx, shows you what your original is doing. In fact, it actually gives you a picture of your original as these are going in certain shapes. So let's find the particular solution. Let's separate our variables. You see how I put this over here. Now completely separate your variables. So I want to get y over here, and over here I have -1 over x dx. We'll get better and better at these integrals with the 1 over. This gives me ln y equals -ln x plus c. And I have to rewrite it. E to the negative ln x plus c equals y. It means y equals e to the negative ln x e to the c. Because if your exponents were added, that means you can go back to multiplication with the same base. Now we learned earlier in the year that if you have e, or in pre-cal, e to the ln u, it just equals u. Or if you have like 3 logarithm of 9 to the base 3, it's just going to be 9. So as long as you have a logarithm with the same base, exponents and logarithms cancel each other out. You just have u. So this is y is equal to, now I have to be careful here because this negative exponent's in my way right here. So I'm going to make this e to the ln x to the negative 1 power. And I'm going to make e to the c. We're usually just going to call that c. So now I have y equals c e to the ln 1 over x, because x to the negative 1 is 1 over x. So you have y is equal to c, and e to the ln 1 over x just equals 1 over x. So you have y is equal to some number over x. So let's look at that on the calculator. And how does this fit in with the slope field? So if I put in anything over x, c over x, if I put 3 over x, or if c happened to be negative and I had negative 3 over x, let's look at this one first. So graph, you see how that fits in with one of our slope fields right there, if you can see it. I think I can even be like cooler than that, make it transparent. You can see how if I position a little bit differently it would fit that slope field. And then our other option would be if one of the coefficients ended up being negative, you would get this red graph instead, which you can imagine what that would do. So that's how our slope field makes sense. It would be the red or the blue, depending on what we call our initial condition. All right, so okay. So second page of the worksheet, you're doing matching. Oh, I'm sorry, I skipped a page. So yeah, second page, so you're doing matching. So you have 7, 8. Let's see, it'd been great if I just had put this in, which I did in my other slides, but trying to think how I want to do this because I want to draw them all, but I also may not can find the worksheet. Let me see if I can find it real quick. I might could just find it online because it's a pretty common worksheet. That way I can just import the pictures or talk about the worksheet without having to draw them all. Hope this is the right one. Sorry, the computer's really slow. Let's see, I think it's our exact worksheet. Is it 6? Alright, so let me screenshot this. Go ahead and get them both in. And knock out through 14 real quickly. Alright, so 7 through 10. right, this is the way I do it. That makes it go a little faster because you don't want to. Some of them you can't even do separation of variables. Like some people argue, like, oh, I'll just actually integrate both sides, and when I see the original, like this one, we can probably predict it's probably going to be this one right here, C, right? Because of its wavy nature, we know that the antiderivative of sine is negative cosine, which would fit like a path like this. So I feel really good about that one. But number 8, like I couldn't even undo mentally. So I'm actually going to find the actual slope. I'm going to be very literal and find the slopes. A lot of times what I do is look for zeros and corners so that I don't have to test every slope. So what I mean by that is let's fill some things into this. Let's take this point out here. Let's say that this point is something like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Let's say this point is 6, 4. If I put it in x minus y, I get 6 minus negative 4, which is 10. So it's not that one. And so I'm going to move on looking for this match. So now I'm looking for one that has a really steep slope. That one and that one both have a really steep slope. I also notice these nice zeros, like at 1, 1, 2, 2, 3, 3, 1, 1, 2, 2, 3, 3, negative 1, negative 1, and so on. If you put those in here, you will get 0. Like if x is negative 1 minus y. And so I'm going to put D with this one. I'm going to put C with this one. All right, now let's go to this one. All right, so these are gone. We think we can come back and revisit them. Now let's kind of start over with A and B and see where we want to put those. Now you probably feel, maybe some of y'all feel good about B being here and A being here, because the antiderivative of this, if I separate my variables, you get y is equal to x squared plus c, so I kind of see that's what's happening here. But we can also check it like this. When x is 1, 2, 3, 4, 5, 6, 4, x is 6, so it's very steep. Over here my x is negative 6, 4, and dy over dx is negative 6, and that just fits really good. Let's look at A. Let's look at this corner, and that would be 2 minus y right now is 4. So I get negative 2, which maybe is believable. And over here, all the way across there, I would have the same slope. So this makes me feel good, 2 minus y. What about when y is 2? 2 minus y would be 0 and flat line all along here. So I feel good about my matching. All right, let's do the next one. In fact, you know, for your best interest, I know you're in a hurry, but you may want to pause the video right now and try 11, 12, 13, and 14. Check your answers, and if you got it right, you can just skip on to the next thing in the video, but I'm going to work them out. All right, I'm just going to pick this one. This point is 6, 4. This point in this corner is negative 6, 4. And this point in this corner is negative 6, negative 4. And this point in this corner is 6, negative 4. All right, so how am I going to do that? Let's look at this one and see if it could possibly be a match. If I take half of 6 minus 1, I get 3 minus 1, so I get 2. And so on all of these 6's, I should have a slope of 2, which doesn't look like that's happening here. So let's look around and see which one looks like it has a slope of 2 everywhere. Oh, when x is 6, just when x is 6, sorry. I think that's like maybe happening right here when x is 6. This slope looks like a 2 and a 2. So now I'm looking at 11, maybe will match B. So let's continue on. What happens at 0, 0, 0, 1 if I'm looking at number 11? Half of 0 is 0. And so when x is 0, your slope would be -1. I might test them one more thing, but I feel pretty good right now about if I'm matching, calling this one B. All right, let's go to this one. Let's go back to A just to get started. This is half of y. Half of 4 is 2. Well, that's certainly not happening here. And so let's move on to C or D. Half of 4, this is a 0.64. Half of 4 is 2. This 0.6 -4, half of that is -2. Up here and down here, I feel pretty good about this one being C. And you could check a couple other things. We will if we need to. All right, on 13, what if I put x over y? So going back to this one, just trying to guess things, I get -6 over 4, which is -3/2. Well, that's not happening on A. It does look like it's happening here. In fact, this looks circular. This one actually would turn into a circle if I separate the variables. Do you see how you get circles of different radii? So I feel good about that one. And so I'm going to call this one D. And so this one should be A. We'll look at it just a little bit. 6 plus 4 should be 10. At this one, we have 6 plus -4, so I get 2, which I guess I'm okay with. Right here, these are 0. And I feel good about that, because that would be 1, -1, like -2, 2, and x plus y there would give me 0. So I feel good about B, C, D, A. And now you could flip back and check and see how we did. The answer sheet has 7C, 8D, 9A, 10B, 11B, 12C, 13D, and 14A. All right, let's look at 14 a little bit closer. 14 is dy over dx equals x plus y. Again, the reason these slope fields are working is you're actually graphing the slope. So it's like if you're laying bricks and you wanted to tilt the brick this way and tilt the brick this way and tilt the brick this way and tilt the brick this way. You're putting the slopes down, but what you're actually doing is making a picture. All right, so anyway, if I separate my variables, oh, I'm sorry, not on that one, on 13. I couldn't separate the variables on this one actually, right here on 14. All right, I'm on 13. All right, so dy over dx equals -x over y. Separation of variables mean get all your y's on one side and all your x's on the other side. Integrate y squared over 2 equals -x squared over 2 plus c. Oh, by the way, I haven't addressed this. You might wonder why I'm not putting plus c on both sides. But if you get a constant on this side and you get a different constant on this side, you just add them together for one constant. So it's okay just to put it in there once. Now if I multiply by 2, I get y squared equals -x squared plus just another constant. You don't need to call it 2c. Doubling it, it's not going to change your constant. Solve, get your x and y on the same side and you get a circle of different radii depending on what c is. All right, so number 15. So 15 is sort of a matching too, in a way. But let's see, does it continue being the same thing? Yeah, it looks like I've got a little bit bigger graph here than what you have on your paper, but I think it'll be okay. All right, 15. Oh, different one, sorry. So this is what you're looking at on 15. Your picture's a bit smaller. I suspect that it's this one, just off the top of my head, because ln x looks like this. But let's check it. Which of the following could be a specific solution to the differential equation? All right, so think about what y equals x squared looks like. E to the x, its slope should be close to 0 and then growing. Y equals e to the negative x. If you make an xy chart and you put in 0, you get 1, and it goes this way. Cosine we'd expect to be wavy. So ln x, let's take the derivative and look at the slope field. Let's call that dy over dx. All right, I know that you still need work on logarithms. The derivative of ln x, or a logarithm, you say 1 over x, and then while you're down there you say ln of the base times the derivative of x, but you just get 1 over x. So if x is 0, right, getting close to here, you should have vertical tangents. When x is 1, you should have slopes of 1, and you can't really, you can see it a lot better on your sheet because you're not sure. Oh, this is 3. So this is 1, kind of 2, 3, maybe not quite like that. So on here, right, that would be about 1, and it looks better on your sheet. And as x gets bigger, your slope should get smaller and closer to 0. And so it's y equals ln x. Notice the difference here. You're actually looking at the original and basing your slope field on the original graph. Y equals ln x, looks like that. Okay, and then number 16. All right, so 16, same thing. We're looking at the original. I'm going to rule these out for now because it looks like that it's doing something more. In fact, the graph looks a lot like an x cubed graph, so I'm thinking it's this one. Let's take the derivative of that, dy over dx. Bring down your 3, you get 1/2 x squared. Now let's talk about what our derivative is, what our derivatives are. At 0, our derivatives should be 0. When x is 1, our derivative should be 1/2. Which you see right here. And as x gets larger, your slope should get larger. Until, let's say, if x is like 3 or 4, then you get 4 squared 16 over 2, which is 8. When x is negative, it doesn't matter, it's squared. So anywhere you look, you should have these positive slopes. And so 16 should be D. And I have been checking my answers as I go. 16 is D and 15 is E. Did we get E for 15? Yeah, okay. So now we're on number 17, which is a free response problem from a real calculus test. 17, consider this is called a differential equation because it's written as differentials. dy over dx equals xy over 2. All right, so on the axis provided, sketch a slope field and only do it on the ones that they give you. Don't do any dots they didn't give you. Usually they don't even ask for, this is kind of a bit much, but, and I don't see a dot at 0, so I'm going to leave that out for now. But I think it's kind of hard to tell here. But they would have a sheet for you on your pink booklet. All right, so if x is equal to 0, your slope is going to be 0. Okay, and if y is equal to 0, also your slope is going to be 0. When y is equal to 0, your slopes are also going to be 0. Oh, I got those backwards again, sorry, but it worked out okay this time. I don't have to go back and redraw it. Oh no, I did that right. Okay, now let's go to 1, 1. At 1, 1, your slope is 1 times 1 over 2. So my slope would be 1/2. At 1, 2, right up here, my slope would be 1. At 2, 1, my slope would be 2 times 1 over 2, or it would be 1. At 2, 2, my slope would be 2. At this point, 3, 1, my slope would be 3 times 1 over 2, or 1.5, a little steeper than what I had here at 1. And then at 3, 2, my slope is 3, so pretty steep compared. And these slopes should be like in all the same color. Okay. At 1, negative 1, my slope is negative 1/2. So kind of a little towards 0. At 2, negative 1, my slope is negative 1. And at 3, negative 1, my slope is negative 3/2. Back here at negative 1, 1, look at your point, don't make a mistake, it's negative 1/2. At negative 1, 2, my slope is negative 1. At negative 2, 1, my slope is negative 1. And at negative 2, 2, my slope is, negative 2, 2, sorry. At negative 2, 2, my slope is negative 2. Down here at negative 1, negative 1, my slope is 1/2. And at negative 2, negative 1, my slope is 1. Alright, so I've got my slope field. Alright, B. Let y be the function that satisfies the differential equation. Let f be the function that satisfies the differential equation. Write an equation, good old-fashioned tangent line at 1, 1, and use your tangent line to estimate f of 1.2. This is linear approximation. Let's be literal. Write the equation of the tangent line at 1, 1. My minus 1 equals m times x minus 1. And I actually know the slope at 1, 1 is 1/2. So I did the first part, and now I'm going to use my equation to estimate f of 1.2. So y is equal to 1/2 x minus 1 plus 1. I'm just solving for y. I'm going to fill 1.2 into my line. So I get 1/2. 1.2 minus 1 is 0.2 plus 1. And so I believe I get 1.1. So I'm going to say f of 1.2 is approximately equal to 1.1. All right, now, all right, so let's go to C. Find the particular solution at 1, 1. So now we're actually going to find the equation and fill in f of 1.2. And we're going to see how good this approximation is. So let's do that. So go back to dy over dx equals xy over 2. All right, I'm going to separate my variables. So I want this y to be over here, so I'm going to divide by it. And x over 2 dx comes over here. So it's called separation of variables. So this dx comes over here with the x over 2, and the y goes over here. Remember how I said leave as much behind as you can. Now integrate. You'll get used to this as ln y, and this one is x squared over 4 plus c if you do that carefully. Remember to add the plus c, takes care of both constants. Now you're not through until you solve for y. So this gives me e to the x squared over 4 plus c equals y. So y is equal to e to the x squared over 4 times e to the c. Since my exponents were added, I know they were multiplied. E to the c is just its own constant, c e to the x squared over 4. And then you fill in the point 1, 1. So I have y is equal to c e to the x squared over 4. I know y is 1 and x is 1. So I get c is 1 over e to the 1/4. So my equation is y is equal to c 1 over e to the 1/4 e to the x squared over 4. Don't remember that answer, so I hope I didn't mess something up. I think I think that's fine. We may want to write this as this, e to the negative 1/4. So now I have y equals e to the negative 1/4 e to the x squared over 4, which I can add my exponents and get x squared over 4 minus 1/4. When they're multiplied, I can add my exponents, and that's what they have on the sheet. Now, with a calculator, I'll actually find f of 1.2. What we just did was we actually found the equation that would fit actually on this slope field if you graph it, which we're not going to do right now. F of 1.2, I would say e to the 1.2 squared over 4 minus 1/4. So I guess we'll do that on the calculator. You're going to be working a lot more with E and LN, so make sure you're doing your homework. All right, so I have E to the, what did I have? It's down here. 1.2 squared over 4 minus 1/4. And I get 1.116. All right, so that's what it actually equals, 1.116. And then D, compare your estimate found in part 1 with your estimate found in, part B with your actual value. This is the actual value found in part C. Was your estimate from part B an over or an underestimate? So we estimated 1.1 and it was less than the actual, and so for some reason we can actually see that it's an underestimate. But we've got to say y from our slope field. So it's an underestimate. Now why would linearization be an underestimate? It's because our slope, dy over dx, at 1, 1, you can see that the slopes are increasing, which means my second derivative, oops, I don't know what just happened. My slopes are increasing, so its derivative would be positive. My slopes are increasing at 1, 1. So the second derivative, which I always forget how to write, I think it's like that. My second derivative, if the slopes are increasing, would be positive. So that means so f of x is concave up. That's enough said, but if it's concave up, your linear approximation is an underestimate. All right, let's do, you'll get to do a bunch of these by yourself, but let's go on and do 18, since you haven't seen these. 18 dy over dx equals x over y. Another actual multiple choice. Unfortunately, we got a lot of points to find. I'll hurry. Maybe I can shortcut it some. These dots are right here. Don't find it on anything that they don't tell you where the dots are. Alright, so at 0, 1, 0, 2, and so on, we're going to get 0. At 0 over 0, I'm not going to do anything. At 1, 0, 2, 0, did I mess it up again? 0, 1, 0, 2, okay. Okay, yeah, these are undefined. So these are all vertical. I didn't put them in very good order. You can do better than me. At 1, 1, I get 1 over 1. At 1, 2, I get 1/2. At 1, 3, I get 1/3. So I might make that a little bit bigger. At 2, 1, be careful, I get 2, so steeper. At 3, 1, even steeper compared to what you've done so far. At 2, 2, you get 1. And at 3, 3, you're going to get 1. And as you are at all of these. At negative 1, 1, right here, you're going to get negative 1 in all of these places. Okay. Now let's go to 2, negative 1. All right, x over y. You get negative 2, so a little steeper. And then at 3, negative 1, you get negative 3, negative 1, you get even steeper. And then at 3, negative 2, x over y, you get negative 1.5. And at 3, 2, you get, this one was 1, you get 1.5. At 2, 3, you get 2/3, so not quite 1. And back here at negative 1, 2, you get negative 1/2. Kind of trying to make it like that. At negative 1, 3, which I hope I did 1, 3. Negative 1, 3, I get negative 1/3, so even more. At negative 2, 3, you get x over y, negative 2/3. It's almost negative 1. Negative 2, 1, you get negative 2, so pretty steep. Negative 3, even steeper. Negative 3, 2, you get negative 3/2, negative 1.5. It's kind of hard to draw, but it works out. So here I get negative 3, negative 1. So that'll give me 3, so pretty steep. And negative 3, negative 2. We get negative 3 over negative 2, we get 1.5. And then here we got 1. Negative 2, negative 1 gives me 2, so pretty steep. And right here, negative 2, negative 3 gives me 2/3. And negative 1, negative 2 gives me 1/2. And negative 1, negative 3 gives me 1/3. And 1, negative 2 gives me negative 1/2, negative 1/3. And then this dot is 2, negative 3 gives me negative 2/3. Okay, so that's weird looking. Oh, and we have dots at, oh, I did, these are vertical tangents. So it looks really weird, okay? And we could probably find this one online, but I'm not going to right now. Let's keep going and see if it makes sense to us. So now let's go to the B part. Okay, so B, sketch a solution curve that passes through 0, 1. So we have this dot at 0, 1, and here's a really good heads up. Sometimes I like have a hard time following where this is going through 0, 1. Actually, like I do get lost. You saw that in class today, but it's not just me. It's pretty common. Sometimes I'll wait and draw it when I know it. So I'm going to bypass B and go on to C. As you'll see, I'll know more in just a minute. All right, on C, find the particular solution. That means find y. So dy, I'm going to move dx over here. Keep going until you get all your y's on one side and all your x's on the other. Integral. So we're back to ln y. You won't always get a logarithm, but we are right now. So that gives me e to the x squared over 2 plus c equals y. So y equals e to the x squared over 2 times e to the c. E to the c is just another constant. Okay. And now I want the particular solution at 0, 1. So there's all sorts of graphs that like this that could go through this anywhere. And I want what's going through 0, 1. So I'll fill it in for y. E to the x is 0 squared over 2. So I get 1 equals c e to the 0. So I know c is 1. So my equation is just y equals e to the x squared over 2. Oh, I've done something wrong. Hang on, that's not the equation they got. So wrong. Oh, I'm so sorry. Wow. Wish there was some way for me to edit this. It's a whole lot easier than that. Sorry, students. Sorry about that, girls. So sorry. Goodness. All right. When I separate my variables, you may have noticed I had done it wrong. Move your dx over here. And like I said, you won't always get logarithms. I should not have had a 1 over y. Just multiply by y. And my life is a lot easier. Y squared over 2 equals negative x squared over 2 plus c. But you have to solve for y. This is real important. Multiply by 2. No reason to say c times 2 is just a constant. And then square root. Y is plus or minus the square root of x negative x squared plus c. Or c minus x squared. Now, since we're going through the point 0, 1, we know that we're going through this point 0, 1, making it really big right here. And so we know whatever we've got is where y is positive. So now I make my decision y is equal to the square root of c minus x squared. Then I fill in my point. Y is 1 is equal to the square root of c minus x squared. So 1 is equal to the square root of c. Square both sides and you get c is 1. So the answer to c is the positive because they gave me this point. If they'd given me a point down here, I would pick the negative. Is the square root of, I'm still messing it up. I'm so sorry. What am I doing wrong? Oh, I am so sorry, girls. It's late here at school. Ah, so sorry. I probably should find some way to edit this. This was x over y, not negative x over y. But it's an easy fix. So I just got to get rid of this negative. It was never there. Not just cheating. It was just never there. So be careful. And so this is positive. So I have 1 plus x squared. So I finally got it. So sorry. All right, 1 plus x squared is going to go like this. At 0, you get 1. So now I know what it looks like. I can actually find points. At 0, I get 1. And then if I fill in, I guess I'll fill in 1. I get square root of 2, which is about 1.414. And if I fill in 2, I get the square root of 5, which is about 2.2. So the square root of 1 plus x squared is going off like this. All right, now let's look at it. I'm not sure I did that right. And I'll show you what I'm thinking here in just a minute. There's a way to check this, but in case it's a non-calculator problem. All right, so this is the square root of 1 plus x squared is the part that goes through 0, 1. Oh, sorry. I should have thought about that. I knew something was kind of wrong with that, and I didn't know really what. So let me undo that. I didn't feel good about how my slopes were going there anyway. You can see I wasn't really trusting them. I wasn't really following them. But it's going to come through like this. And I don't know if you really want to put an arrow on it or not. It doesn't really matter when you just do that. Draw the solution curve. All right, now how I would have known what that looked like, and I know a lot of you aren't good at hyperbolas, but if you solve this, you get y squared minus x squared equals c. When you have squares with a hyperbola and y is in the front, you have things that look like this. So that's why that's happening. All right, now let's go through. So now I've answered the B part. I drew the solution curve. And then D, find the particular solution that would go through 0, -1. And so we are back at the same location, and we fill in 0, -1. So I get -1 equals the square root of c minus x squared. So I get -1 equals the square root of c. Square both sides, you get c is 1. And so I have the same equation. However, if I'm going through 0, -1, I have this one. And so if I'm going through c is equal to -1, my equation for D would be y is equal to the underneath part of 1 plus x squared. Let's see if we can, well, we'll just look at it back on the calculator. If I put in the negative in front of that, oops, sorry. We get this, and it'll go through 0, -1, which matches our slope field. So it depends on where your equation is, what you get. All right, so now we're going to another video. So I'll just stop this one for now and call it